Look at New York City today. It is a soaring canyon of reflective glass and towering steel grids. To understand how this metropolis was actually built, you have to mentally strip all of that away. Erase the glass, melt down the steel, grind the stone back into dust until you are left with nothing but a bare, wooded island on the edge of the Atlantic. In the early 1600s, the Dutch established New Amsterdam as a survival mechanism, a modest trading post clinging to the southern tip of Manhattan Island. The architecture of this era was strictly utilitarian. Colonists relied on timber from the surrounding forests and simple brick to withstand the harsh coastal climate. Physical material limits and the pragmatic need for shelter dictated the early silhouette of New York. To maximize the structural stability of their timber, the Dutch employed an engineering technique known as the anchor bent. It relies on a sturdy H-shaped frame, using two thick vertical posts locked tightly together by a heavy horizontal anchor beam. By lining up multiple anchor bents in a row and connecting them along the top and bottom, builders could erect an incredibly rigid skeleton. This system distributed the structural weight efficiently, leaving the interior spaces wide open for living and working. This framing technique naturally produced the defining visual characteristics of Dutch colonial design, those steeply pitched gable roofs and extended eaves you still see on historic rural homes across the Hudson Valley. But down on Manhattan Island, a geographic reality quickly set in. As the trading post's population boomed, horizontal space evaporated, forcing settlers to build these timber frames closer and closer together. That density exposed the fatal flaw of wood construction. In the winter of 1835, a massive fire swept through Lower Manhattan, incinerating hundreds of these tightly packed buildings. In the aftermath, the city passed strict ordinances, legally limiting the construction of wood frame houses. The combination of extreme population density and catastrophic vulnerability to fire forced the city into its next evolution. New York abandoned its founding material and pivoted toward heavy, permanent masonry. As the Industrial Revolution took hold, an explosion of economic growth allowed developers to import immense quantities of brick, marble, and Connecticut brownstone. They blanketed the expanding residential districts with these dense, fireproof row houses. This wealth also triggered an appetite for prestige. The city's elites embraced the beaux arts and classical styles, using highly ornamented European-inspired architecture to project their cultural dominance and financial power. You see the ultimate manifestation of this heavy, opulent aesthetic in the major civic transit hubs of the era, where massive, load-bearing masonry arches communicate absolute permanence. But solid stone carries a strict physical penalty: weight. As land values in Manhattan skyrocketed, developers needed to build taller, and thick masonry walls were simply too heavy and too expensive to scale endlessly upward. The solution emerged in commercial districts like SoHo through the mass production of cast iron. Foundries prefabricated lightweight metal facades that perfectly imitated the elaborate classical carvings of stone, but at a fraction of the weight and cost. Cast iron proved to be a vital evolutionary bridge. It liberated builders from the structural limitations of thick masonry blocks, while still satisfying the Gilded Age demand for grand, repetitive ornamentation. The true vertical breakthrough arrived with the internal steel frame. By riveting together a rigid grid of steel columns and beams, engineers completely removed the load-bearing burden from the exterior walls. Paired with the invention of the reliable passenger elevator, this skeletal engineering triggered a relentless, unregulated race into the sky. Developers pushed these sheer towers so high that they threatened to plunge the streets below into permanent, unbroken shadow. In response, the city passed the 1916 zoning resolution. This spatial law introduced the setback requirement. It mandated that a building's mass restrict itself to a specific percentage of the lot size, angling inward as it rises to preserve a corridor of sunlight for the sidewalks below. Architects adapted to this invisible boundary by designing stepped wedding cake structures. they tapered the tops of their towers and capped them with steel spires, birthing the iconic Art Deco silhouette. The Art Deco shape is a direct physical compromise. It represents the exact intersection where the limitless vertical strength of a steel frame meets the strict legal necessity of urban sunlight. Following the Second World War, architectural tastes shifted sharply. Designers abandoned the heavy ornamentation of previous decades in favor of the international style, prioritizing pure, unadorned structural efficiency. This era mastered the concept of the curtain wall. Because the internal steel skeleton supports the entire weight of the building, the exterior walls don't need to hold anything up. They can be hung onto the outside of the frame like a lightweight skin. This precise engineering allowed for skyscrapers clad entirely in sleek glass and metal, erasing the functional need for heavy stone facades altogether. In the 21st century, these continuous glass curtain walls serve as advanced green engineering systems. They feature high-performing insulation and shading elements that maximize natural daylight while drastically reducing energy waste. These weightless, transparent sheer planes stand in stark contrast to the thick, dense masonry and heavy timber frames that defined the city's origins. The skyline of New York serves as an architectural fossil record. Every transition from timber to stone to steel to glass maps humanity's escalating ability to manipulate raw materials, conquer gravity, and optimize vertical space.